Let's go over today's challenge. Right here, I have a bin full of atoms. A lot of atoms. 2 isotopes. We have the white version and the black version. You counted the atoms, 830 atoms in the bin. And your job was to determine how many of those total were white pieces. The formula I'm going to use is M1, P1, plus M2, P2 is the atomic mass. Which is a weighted average. Since I know the total number of atoms in my bin, 830, if I can measure the total mass of all the atoms, I can calculate the average mass. I'm going to zero out my weight container. I'm going to do this in parts because all that is not going to fit in there at one time. 680.84. So right here off to the side, 680.84 grams. And let's move that. Got an empty bin over there. $837.56. I knew that was going to happen. $1270.25. So there's our total mass, 2788.65. What did I just say? Yeah, that's what I said. I just got my... these are not lined up. There we go. Let's just check it one more time. 2788.65. So there's our total mass. And we can divide that by the total number of atoms, which is 830. The average mass, which is stored in my calculator, but I'll just trim the 3 sig figs, 3.36. That's the average mass of each of the 830 atoms in that bin. Let me get mass of the first isotope. We'll just call this white. And we'll call this black. Now these are probably all identical, but I don't want to take a chance, especially because I can put a bunch on here. That's what I'm going to do. Just put a handful on there. 22.00, 22.01. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be 2.2 is going to be the average. But we can use our calculator to confirm. 22 divided by 10 is 2.2. I'll go with that. All right. 2.20 grams is the mass of the white isotope. And we're going to multiply that by the relative abundance, the percentage of the white isotopes. And we're going to add that to the mass of the black isotopes. Again, if we mass only one, there's a chance that there could be something unusual about that. So I'll just get a handful of these black pieces. 1, 2, 3, 4, 5, 6. So 31.10 divided by 6. The average mass of the black pieces is 5.18. And we're going to multiply that by its relative abundance. This is the guy we want that will give us the answer to the problem. How many pieces are white? Let's call this X. And because we only have two isotopes, those two relative abundances have to add up to 100%. And 100% in decimal form is 1. So we can say if that percentage is 1, then the percentage of the black isotopes is 100% minus X, or 1 minus X. Let's solve for X. This here is that. We're going to distribute. Let's isolate the x's. On the left side, we can subtract both sides by 5.18. Negative 1.82 is what we have on the right. And on the left, we'll just combine them. So it's 5.18 minus 2.2. We don't need a calculator for that. Whoops, almost forgot my x. Now we can divide through by negative 2.98. To isolate the x. So we got 61.9 0.1%. I'm going to use that. That's the decimal form of the percent. Over here. So 830 is the total number of atoms, and 61.1% of it are white. I have a feeling many of my students are going to get better numbers than me. We'll see. Oh, I can't. My up arrow is broken. Okay. $507. I need to round to whole numbers because I'm asked to count how many of them are white. 507 is my answer. All right. It turns out there were 509 white pieces in the bin. I'm a little surprised I did better than my students because usually I mess things up in the lab. Here are the initials of the top 3 in 2025. And I'm just noticing this now, but all 5 of these students, I don't think used the method that I used. I think they more or less guessed or did rough estimations. So maybe the lesson for this is that the students that do everything right, the proper way, may not always get the best results. And luck is definitely a big part of science. And that probably also explains why I came in first place. And by the way, let me know if you know a better way to solve this challenge.